All right. Welcome back, everyone, to another deep dive. Today, we're going to be looking at transistor switch circuits,
Oh, yeah. Some really cool
the
stuff.
ones that can react to changes in light or temperature.
Yeah. Automatic night lights,
Exactly.
temperature-controlled fans.
All thanks to transistors. But before we get ahead of ourselves,
Yeah.
we have some notes here called the N5 electricity notes
Mm-hmm.
that kind of lay out all the basics.
Right.
So we've got transistors,
Mm-hmm.
NPN, and MOSFET types,
Yep.
thermistors,
These are important.
LDRs, resistors.
Yeah, so many pieces, right? To this puzzle.
It can be a little overwhelming,
Yeah.
but once you get it,
Once you understand how each one works on its own, then we can start putting them together.
like building blocks.
Yeah. And that's where the fun begins.
Exactly.
So that's where the aha moments come.
Yeah, so let's start with the transistor itself.
Okay.
It acts like a gate, right?
Mm-hmm.
Controlling whether current flows through. But what tells the gate to open or close?
That's a great question. And this is really where it starts to get interesting because it's the voltage.
Okay,
So the voltage is what tells the gate to open and close.
got it.
But the way we arrange the components and specifically where we put the transistor really dictates which voltage is kind of the boss of the circuit.
Okay, hold on. I need to grab my notebook because I can already tell this is where things get really interesting.
It is.
So we've got our sensor,
Okay.
right? And that's either a thermistor reacting to temperature or an LDR to light.
Mm-hmm.
And it's connected in series with a resistor.
Right.
And the N5 electricity notes mentions both fixed and variable resistors. We'll
Right.
get to that later.
Yeah, absolutely. That's a really key part in controlling when our transistor switches. But first, let's imagine just the transistor connected across the sensor itself.
Okay.
So that's kind of setup number one.
Okay. I'm picturing it.
Yeah.
So the transistor is essentially measuring the voltage
Uh-huh.
directly across the sensor.
Right.
So as the temperature changes,
Mm-hmm.
the resistance of the thermistor changes.
Yeah,
And that then messes with the voltage.
you got it. And the same with an LDR and the light level.
Okay.
Now, each transistor has a specific switch-on voltage,
Okay.
and it's kind of like a key fitting into a lock.
Okay.
If the voltage across the sensor reaches that magic number,
Yeah.
the transistor will turn on and let current flow.
So the sensor is basically sending a signal to the transistor saying,
Exactly.
like, hey, it's hot enough or it's dark enough.
It's giving it a signal.
And then that flips the switch.
It flips the switch, exactly.
This is so cool.
It is cool, but there's another piece to this puzzle.
Okay.
Remember that resistor that's in series with the sensor?
Yeah.
Well, the voltage across that resistor is also changing,
Okay.
but in the opposite direction.
Hold on. I need a visual.
Okay.
So if the voltage across the sensor goes up, the voltage across the resistor goes down,
Exactly.
like a seesaw.
Perfect analogy. The total voltage in the circuit is kind of like a fixed budget, and it has to be split between those two components.
Right.
One goes up, the other goes down, and it's this interplay that makes these circuits so responsive.
Wow.
Yeah.
Okay. I'm feeling pretty good about setup number one.
Okay.
But what happens when we move the transistor and connect it across the resistor instead?
Ooh.
Is that where things get really wild?
That is where things get wild.
Okay.
Yeah. Yeah. It's like we flipped the whole script now, right?
Oh.
Because now the transistor is listening to the voltage across the resistor
Right.
instead of across the sensor.
Got it.
The sensor still does its thing, reacts to the environment, changes its resistance.
Yeah.
But it's the resistor's voltage that's going to determine whether the transistor switches on or off.
So the voltage across the resistor has to hit that magic switch on voltage.
Exactly.
Yeah.
And remember, the resistor's voltage is changing in the opposite direction to the sensor's voltage. So that means the whole behavior of the circuit is reversed.
Yeah. Okay, hold on. Let me see if I've got this straight.
Yeah.
Let's say we're using our thermistor again,
Okay.
and it's getting hotter.
Mm-hmm.
In the first setup, the transistor would have turned on when it was cold,
Right.
because that's when the thermistor's voltage is high.
Right.
But in this second setup, it's going to turn on when it's hot,
Yeah.
because that's when the resistor's voltage is high.
Exactly. You've got it.
Woo!
Isn't that amazing how simply moving the transistor
Yeah.
changes the whole logic of the circuit?
It's like we've turned our cold detector into a hot detector,
Yep.
just by like rearranging the pieces.
Exactly.
Wow. Okay, so give me a real world example because I'm ready to see this in action.
Okay. Right. Challenge accepted. So let's say you're building a temperature controlled fan
Okay.
to keep your super secret electronics project
Yeah.
from overheating.
Mm-hmm.
Let's say we're using an NPN transistor
Okay.
because they're really calm and easy to work with.
Yeah.
So we've got our thermistor, resistor, transistor, and our fan, of course.
Got it.
All wired up.
Okay.
Now first, let's imagine that the transistor is connected across the thermistor.
All right.
So in this configuration, remember, the transistor is watching the voltage across the thermistor.
Right.
As the temperature climbs, the thermistor's resistance drops.
Right.
And so does the voltage across it.
Mm-hmm.
And at some point, it'll fall below the transistor's switch-on voltage.
Oh.
The transistor will turn off, and the fan will stop spinning.
Oh, so it's like a safety mechanism.
It is.
So the fan runs when things are cool.
Yeah.
But as soon as it starts to get too hot, it shuts off.
Right.
To prevent any damage.
Yep.
That's clever. But what if we wanted the fan to kind of do the opposite? So turn on when it gets hot.
Well, that's where we move the transistor.
Okay.
So if we connect it across the resistor instead, the whole system kind of flips.
Right.
So now as the temperature rises and the thermistor's resistance drops, the voltage across the resistor increases. And when it hits the transistor's switch-on voltage, the fan kicks into gear.
Oh, wow. So we can literally choose which temperature range triggers the fan.
You can.
Just by deciding where to put the transistor.
That's the beauty of it.
That's amazing. Okay, hold on. I need to process this for a second.
Take your time. It's a lot to take in.
Yeah.
But once you get it, it opens up so many possibilities. We've been talking about temperature, but the same principles apply to light-sensitive circuits with LDRs.
Oh, so we could build a light-activated alarm.
Exactly.
Or maybe a solar-powered robot that follows the sun.
Absolutely.
Oh, my brain is buzzing with ideas.
And there's one more trick up our sleeve that gives us even more control over these circuits.
Okay.
The variable resistor.
Oh, yeah, the N5 electricity notes mentioned those.
They did.
I have a feeling this is where we take our circuits to the next level.
It is.
Okay, tell me more. Okay. I am officially geeking out over here.
Yeah.
Variable resistors. They're like the secret sauce.
They are.
For really fine-tuning our circuits.
Yeah, they're like a volume knob for voltage.
Okay.
It allows us to adjust the resistance, which directly impacts how that voltage is shared between the components in the circuit.
So let's go back to our temperature-controlled fan example.
Okay.
With a fixed resistor,
Right.
we're kind of stuck with that specific temperature range.
Yeah.
But with a variable resistor.
Oh, now we have so much control.
Yeah.
Imagine wanting the fan to kick in at a really precise temperature, like 80 degrees Fahrenheit.
Oh, wow.
By swapping out that fixed resistor for a variable one and carefully adjusting it, we can pinpoint that exact switch-on point.
Wow, that's so precise.
It is.
No more guessing.
No.
Or like messing around with different resistor values.
Exactly.
We can literally dial in the perfect temperature.
You can?
Yeah.
But how does it work practically?
Okay, so let's say we've got our transistor connected across the thermistor.
Yeah.
In this setup, remember the fan is on when it's cool.
Because the thermistor's voltage is high.
Right.
As the temperature climbs, the thermistor's voltage drops.
Yes.
And eventually it'll fall below the transistor's switch-on voltage, turning the fan off.
Right.
Now imagine we've added a variable resistor in series with the thermistor.
Okay.
By tweaking the resistance of that variable resistor, we can actually manipulate that crucial voltage point.
Oh.
We can make the fan switch off at 75 degrees,
right.
80 degrees, 85 degrees, whatever we need.
So we're kind of shifting that switch-on voltage up or down the temperature scale.
Exactly.
This is amazing.
And the beauty is it doesn't matter which configuration we're using.
Right.
If the transistor's connected across the resistor, instead, the variable resistor still gives us that level of control.
Okay, I'm seeing the pattern. Variable resistor ultimate control.
You got it.
Let's switch gears to our light-activated alarm.
Okay.
How would we use a variable resistor to make it more or less sensitive to darkness?
Okay, so imagine we've got our MOSFET transistor connected across the LDR.
Yeah.
Creating an alarm that triggers in low light by introducing a variable resistor in series with that.
Okay.
We can fine-tune how dark it needs to be for the alarm to go off.
So we can make it super sensitive.
You could.
So it triggers at the slightest dip in light.
You could.
Or we can make it so it only activates in like near pitch black.
Absolutely.
A possibility.
A motion-sensing nightlight that gently illuminates your hallway as the sun sets.
Yes.
Or a security system that only blares when there's zero ambient light.
This is incredible. We've gone from understanding how a single transistor acts as a switch
I know, it's amazing.
to building circuits that respond to the environment.
Right?
In all sorts of clever ways.
And it all comes down to those basic building blocks.
Yeah.
You know, the sensor, the resistor, and the transistor.
Yeah.
By understanding how they interact and how their placement affects the circuit's behavior, we can really unlock a world of creative possibilities.
I can't wait to start experimenting with these circuits myself.
Me too.
This has been such an awesome deep dive.
It has.
Thanks for taking us on this journey.
Absolutely. My pleasure. And remember, the key takeaway here is don't be afraid to tinker and explore and really push the boundaries of what's possible.
Yeah.
Who knows what amazing inventions you might create with the power of transistor switch circuits.
Amazing. Thanks again.
You're welcome.